All right, today we're going to be talking about chemical equations and balancing chemical equations. So first of all, with chemical equations, you've kind of got three different types that you'll see. You'll see the equation actually written out in words, like this example here, copper reacts with chlorine to form copper 2 chloride. Or you can see simplified equations where it still shows the names, but instead of saying all the words, there's these symbols to represent things coming together and making new stuff. And then the final form is the most typical form in chemistry, which is the formula equations, where you use your chemical formulas and symbols to represent the compounds and the elements that are coming together to have the reaction occur. This in chemistry means the exact same thing as this whole sentence here. So the way that chemists would say this is copper and chlorine yields copper 2 chloride, or sometimes they would say copper and 2 chlorine atoms yield copper 2 chloride. Formula equations are basically used to illustrate that reaction without actually having to write a whole sentence out. So this is the shortcut that chemists like to use because they read this the same way as you would read this equation up here. And that way they don't have to write a sentence. Understand that this arrow means yields, makes, forms, that sort of thing. So this is showing you that the chemical reaction goes forward. The way that chemists say it is they always say yield, and that plus signs are always said as and. Okay, so balancing equations. And a balanced equation demonstrates the law of conservation of mass. And the law of conservation of mass basically says that mass can't be created nor destroyed, it can only be rearranged. So that means atoms can't be created or destroyed. And whatever we start off with, we have to end up with. But they can be rearranged from the reactants, what you start with, into new products. And a balanced equation always has those same numbers for each element on both sides of the equation. It has to, otherwise you're violating the law of conservation of mass. All right, so let's look at an example. We've got carbon and oxygen, an oxygen molecule, notice they're attached here, yielding, this is carbon dioxide. We've got two oxygens here and a carbon atom here. So this is making carbon dioxide, the stuff that we breathe out. This is our chemical formula for this reaction. And look, it says the same thing, carbon, oxygen. Notice the 2 here representing the 2 oxygens together as one oxygen molecule, and carbon dioxide, again, 2 oxygens on here with the 1 carbon. This equation is actually already balanced. If we look, we have 1 carbon on our reactant side, we have 1 carbon on our product side. And if we make a little table, we can see that as well. Carbon on the reactant side, carbon on the product side, 1 of each. And we also have 2 oxygens on our reactant side and 2 oxygens on our product side, although they have rearranged. In the beginning, we had an oxygen molecule, 2 oxygens bonded together. And on our product side, after the reaction occurs, they are now bonded with the carbon atom to make carbon dioxide. But in both cases, we have 1 carbon atom on both sides, just like we showed in our table. And we have 2 oxygens for both the reactants and products, just like we showed in the table here or in the visual picture of the reaction taking place. What if it's not balanced, though? And that's what we're going to spend the rest of the lecture talking about, if it's not actually balanced to begin with. Well, let's look at another reaction. Same stuff to start with. Carbon atom and an oxygen molecule, 2 oxygens. However, we're making something new now. This is called carbon monoxide. So we don't have the same product that we had to begin with. So if we start our table, we get our equation first of all, a carbon atom and an oxygen molecule yielding carbon monoxide. We have to write our formula correctly, and then we can start our little table. Atoms of each, so we have carbons, and we have 1 on our reaction side and 1 on our product side. And then we've got our oxygens. We have 2 oxygens on our reactant side within that oxygen molecule, but we only have 1 oxygen on our product side. So we need more oxygens in the product. We only have 1 over here, but we have 2 on our reactant side. This is a problem. So we can't change the formula over here. We can't just add an oxygen over here because that would change it and it wouldn't be carbon monoxide anymore. it would be carbon dioxide, or it would be carbon monoxide with an oxygen, and that's not what our reaction shows. Our reaction shows the only thing we make is carbon monoxide. So we've got to do something else. In order for that to happen, we can't change the formula. If we add an oxygen over here, we have to actually add another carbon as well to make carbon monoxide. So we bring another carbon monoxide molecule in, okay? And if we look at our table, now we have 2 carbon atoms over here as well. We have 2 carbon atoms as well as our 2 oxygen atoms. So if we reassess, our oxygens are balanced. We have 2 oxygens on the reactant side and 2 oxygens on the product side. But our carbons are not balanced anymore. We only have 1 carbon over here, and we have 2 carbons over here. All right. The other thing that we have to do when we're balancing equations is after we add what we need to, we also have to put a coefficient in front. So we have to add a 2 in front of each compound or element that we have in order to show that we have multiplied across. Okay, so when we do this, this means that we have 2 carbon atoms, and we distribute this 2, so we also have 2 oxygen atoms. And that's what we can see visually in the picture here, that we have 2 carbon atoms and we have 2 oxygen atoms. They're just in the form of 2 carbon monoxide molecules here. Okay, all right, so that shows that we have 2 carbon monoxide molecules, but we're not happy yet, because we've got only 1 carbon over here, but we have 2 over here. So we still don't have enough carbon on our reactant side, which means we've got to continue balancing. Okay, so what do we need to do? Well, we got to bring in another carbon. That's the only thing we can do. So we bring another carbon in on our reactant side, which means we must have started with 2 carbons in our chemical reaction here. Well, if we brought in another carbon, if we look at our table, now we've got 2 carbons over here. We've got 2 oxygens on both sides. So we're balanced, but we're missing something up here in our chemical equation. We're missing that coefficient. So remember, we have to add the coefficient of 2 in front of the carbon to show that we actually have 2 carbon atoms. So we bring that 2 in front. And now, if we check, we've got 2 carbon atoms on either side. We've got 2 oxygen atoms on either side. If we want to look at the visual to make sure, we've got 2 carbon atoms here. We've got 2 carbon atoms here. We've got 2 oxygen atoms here. And we've got 2 oxygen atoms on our product side. So everything is balanced. So now we have a balanced chemical equation, and that's how you write this particular equation, balanced. So we're saying that we have 2 carbon atoms plus an oxygen molecule yielding 2 carbon monoxide molecules. All right, let's look at what we should actually do for our rules for balancing now that we've looked at one. So first of all, you have to write your correct formulas for all the reactants and the products. If you don't have correct formulas to start with, you can't balance the equation properly. Then you count up all your number of atoms of each type appearing on both sides, like the carbon on the oxygen, and you got to figure out how many you have on both the reactant and the product side. And then you start balancing the elements one at a time by adding your coefficients. Remember, your coefficients are those big numbers that are in front. So you use your little table, your little worksheet table, to figure out how many you need on both sides, and then remember, whatever you multiply it by becomes your coefficient. To figure out how much you have total, you multiply your coefficients, the big numbers, by the subscripts, the tiny numbers, to get the total number of each atom in a compound. And lastly, you check to make sure it's balanced. So you go through this process of balancing the elements one at a time. You check your numbers in front, you multiply your coefficients, make sure you've done that for the atoms, and then you check your table to make sure that each side has the same amount. If they don't, then you keep going. If they do, then you know that you're balanced. Okay? Things that you should never do. You never change a subscript to balance an equation. Why not? If you change the subscript, you're changing the formula. So you're describing a different reaction. For example, H2O. H2O is water. That is not the same thing as H2O2. So if you needed an extra hydrogen, you wouldn't just stick a 2 in here an extra oxygen, you wouldn't just stick a 2 on here behind. This is hydrogen peroxide. This is that stuff that bubbles when you clean your wounds with it. Not the same thing as water. This, you would die if you drank. This is absolutely perfectly fine to drink. You never put a coefficient in the middle of a formula. So if you need 2 sodium chlorides, 2 salts, it's okay to write it with the 2 in the front because that 2 means that you have 2 sodiums and you have 2 chlorines in front. You never write it in the middle like this because, again, that's changing the formula. That's not okay. All right, so let's look at another example. Let's look at taking hydrogen gas and oxygen gas and making or yielding water. All right, so we've got to make sure we have our formulas written correctly, which they are written correctly in this equation. And then we make our table and we start looking at our atoms and making sure that we're okay. So we set up our table with our reactants and then a line to separate our products. First thing we do is we write down what elements we have. In this case, it's very simple. We only have hydrogen and oxygen. You don't even have to look at your product side because by conservation of mass, you got to have the same thing on your product side as your reactant side, but you can double check if you want to. The only thing that's over here is an H and an O, which is what has to be over there. And then you start putting in how many you have. You have 2 hydrogens to begin with because that's the subscript of 2 on the reactant side. You have 2 hydrogens on your products as well because of the subscript. So our hydrogens are balanced, and then we go to our oxygens. We have 2 oxygens on our reactant side, but there's no subscript over here after our oxygen, which means we only have 1 oxygen. All right, this right here is a problem. This tells us that we are not balanced. We've got twice as much oxygen on our reactant side as our product side, which means we need 2 times more over here. We need 2 oxygens in the product. All right, so let's look at that. We need 2 oxygens in the product, so we scratch out our 1 and we put a 2. But on our product side, remember this is water. This isn't just oxygen. So if we change our oxygen, that means we also have to change the hydrogen because that's part of the whole molecule. We're adding another water molecule. We're not just adding oxygen. We can't just add oxygen over here. So if we multiplied the oxygen by 2, we also have to multiply the hydrogen by 2. That gives us 4 hydrogens. All right, so we multiplied both of these by 2, which means we've got to put a 2 in front of our water up here. 2 times H with a subscript of 2. 2 times 2 is 4 hydrogens. 4 hydrogens, that's exactly what we have down in our table here. And 2 times our oxygen over here is 2 oxygens, and that's exactly what we have in our table here. All right, so remember, whatever you multiply by is your coefficient. All right, so then we have to reassess. We got to check. All right, now we got a problem with our hydrogens. Now our fat side is our product side. We got too many hydrogens over here. Not enough on our reactant side. We always mess with the skinny side, the one that doesn't have enough. So now we've got to deal with our hydrogens on this side. Now we need twice as much hydrogen in our reactant, so we're going to multiply by 2. All right, so same thing. We look at our table. We multiply by 2. That gets us to 4. Okay, so since we multiplied by 2, twice as many hydrogens up here, we need to have a coefficient of 2 to show that there's 4 hydrogens. So remember again, our coefficient multiplied by our subscript tells us total how many hydrogens we have. So 2 times 2 is our 4 here. So now we check, we reassess, we look at them. We've got 4 hydrogens on both sides. We got 2 oxygens on both sides. So this equation is balanced. It has the same number of each kind of atom on both sides. All right, so now, final, what do we have left? We have this table down here that we used as sort of our balancing worksheet. And we have our equation up here. This is our balanced equation. So this top part is the actual answer showing the balanced chemical equation, not the work down underneath. So understand that just this is a balanced chemical equation. This is saying we have 2 hydrogen molecules and 1 oxygen molecule yielding 2 waters. Okay. Remember the coefficient in front gets multiplied by the subscript to tell you total how many you have. So 2 times 2 is 4 hydrogens. If we come over to the product side, same thing. 2 times 2 is 4 hydrogens. And then our oxygens, we don't have anything in front, which means 1. So this is 2 oxygens. And then our 2 goes for everything in the compound. So 2 times O is 2 oxygens. Again, this is a balanced chemical equation. The table that you're using down here is just sort of your little worksheet practice to get you to help balancing equations. Eventually, you get good to where you can just look at your subscripts and your coefficients as you fill them in, and you can go back and forth on either side without having to do the table. But right now, I want you guys doing your table underneath to show how many you have of each atom on your reactant side and on your product side, and that you're showing your multiply work so that you know where your number should go into your balanced equation. Remember, it's what you multiply by to get to your new number that is your coefficient, not the numbers that you put down here. Okay? And that is how you balance a chemical equation.